Okay, so this is the class is a tryout for the ACT Math. Okay, ACT Math. The official class will start next Sunday, 12 to 2. So we have 12 weeks. Each week is 2 hours, so totally 24 hours. Here is just my introduction. Okay, I graduated from Colorado School of Mines with a PhD degree in chemical engineering, and I have been teaching at high school in Texas, Sugar Land here for Bend ISD. For many years now, I have taught Algebra 1, Algebra 2, college algebra, pre-calculus, okay, or different subject. And I've been mentoring the new teachers as well. My own daughter also was a student from Momentum Learning. Okay. She enjoyed a lot and then learned a lot. So I want to also just contribute my knowledge and my experience to any of you who needs to be successful or exceed your subject. Okay, so here is the information. So we will focus on 3 different areas. The College Board says the ACT, the math, will focus on part of the algebra, which will focus on linear equations, system equations, functions, okay, so on, and problem solving and data analysis, including ratios, percentage, proportions, okay, and word problems, okay, and also have some statistics, how to read the data, how to analyze the data. Okay, and then there are some problems also for the advanced math, which have some complex equations, functions, and some trigonometry, complex number, radian measure, things like that. Okay, our line out. Okay, our line out is on the Momentum Learning website. So we have week 1, week 2 so far. To week 12, we have some advanced topic, trigonometry, probability, and starting with basic. And not say just the basic. The first couple of weeks are like line out the fundamentals and a lot of the questions. Okay, a lot of questions on the SAT math, having all those foundations over there. Okay, this is my class expectation for the official class. Okay, so today you're welcome to turn on camera or just keep your camera off. But during my class, okay, I need everybody have your camera on and mute until you are called upon. And I need active participation, because it's not like, you just hear what I'm, going over. You need to practice, okay? And I will give you the feedback, okay, through the chat window. So I set the chat is only I will be able to see. So do not feel shy. Just type anything you want to answer or anything you want to ask. And you need to practice homework on regular basis. Okay, and I will give you the key, and you were prepared to bring questions, okay, from the homework to the class. So every week we will have some homework from the textbook, which I will actually also provide, and also some of the sections from the College Board practice test. So on the college practice test, you have totally 8 practice tests. So I will give you different sections for you to practice. Okay, and then usually in the beginning of the class, I will spend maybe 20 minutes, 30 minutes to go over a couple of the questions you have from the homework. If you have any questions, review the recordings. Okay, review the recordings. Any questions so far? Okay, you can type in the chat if you have any questions so far. Okay, if not, I will start. Okay, this is a tryout. I'm going to start just our week 1, the exponentials, radicals. Most of you are high schoolers, so the College Board will change the rules in 2024, but most of you look like you would take the current format of the SAT. So which means you will have 2 sections. One is without calculator, one is with calculator. Both sections actually will give you this reference area. So this is the formula you will be provided on the ACT. So which means, okay, if it is if there's some other formulas, okay, you have to either memorize it or you have to just deduct it yourself. So those are the only thing will be on the ACT. Okay, our first unit, okay, we'll start week 1 will be exponent and the radicals. So just quick review, okay, I believe many of you complete, let me see, a lot of you, yeah, high schoolers, either complete algebra 2 or maybe studied, at least finished algebra 1 and geometry, correct? When you have the algebra 1, okay, we went over all those exponent rules. Okay, I'm going to start with the third one. Okay, and then I will go over the other one. If I have same base, okay, if I have same base, x to the power of m times x to the power n, you actually add those exponents. Okay, you add those exponents. Now, what if you said, I actually forget, okay, the formula is not given, right? So what if you forget? You can use, I will just help you here, say, going to deduct yourself, okay? What should I do? So I'm going to just use 2 random numbers, okay, x² and x3. Do not use both x2 because 2 times 2 is 4, 2 plus 2 is also 4, so you cannot actually tell. So if I use x2 times x3, so I'm going to expand that. X² itself is what? X times x, right? Square means multiply by itself. And x³ is 3 of the x together. Square, and then you count how many x? Oh, 5. 5. You said, okay, I need to do it. The 2 plus 3, which is 5. Okay, so this is just the easy way if you actually forget the formula, because you will see later on we have multiplication, we have subtraction, things like that. Okay, now let's look at the second formula. When you have multiplication, you add. Okay, when you have division, okay, you subtract. And the same thing, if you forget, okay, you can do a quick division. So for example, if I do x5 divided by x2, you're going to expand. X5 is 5 of the x, okay, and then divide by 2 of the x. X, each pair canceled, leaving you just the x3. Okay, so you know it's subtraction. 5 minus 2, subtract. Okay. And when you have a base, but then you have a parenthesis, you have an inside exponent, outside exponent, you multiply the exponent. So same thing, if you forget, do the same thing, okay, x², and then maybe the cube. So it will be x² times x² times x². Okay, and then you can expand all the x², which is x, another x. So totally is x6. So this way you just say, okay, you prove this out. This is, need to be multiplied. When you learn all those rules, okay, you might just mix all those. So this is a just quick way to remind yourself how the rule look like, because ACT will not give you this formula. Okay, now when we have parentheses and then outside you have exponent, okay, so this is basically you distribute. Inside here is default 1 and 1 times m, and so this is, if you have division, it's the same thing. So you distribute m, okay, m here. Okay, we have a very important rule, which is negative, okay, which is a negative exponent. When you have x to the power of negative exponent, you change that to positive exponent, okay, m, but then do the reciprocal. Okay, now I'm going to just go over the first two. Okay, I skipped earlier. Anything to the power 1, of course, just itself. Anything to the power 0 is 1. And you can, if you forget, is it a 0 or is it 1? Okay, you can do a quick x0. So for example, just x² divided by x², because 0 is 2. This is 2 minus 2, right? So it's x2 minus 2, that's the 0. x² divided by x² is 1. Okay, so you can get yourself. Okay, so I went over all those formulas. Okay, now let's look at, okay, some simple calculation, and then we'll do some real problems from the previous ACT test. Some quick ones, okay, because students always will confuse this. Okay, I want you to type in the chat, what is your answer for 1 and what's your answer for 2? So label it so I know which answer is for which. Very good. Okay, I got 4 students. Okay, you don't need to do the 3 and the 4. Okay, just to finish the 1 and the 2. Okay, very good. Now this is a frequent really mistakes for my students always. Okay, when you have parentheses, okay, so this one is -3 times the -3 square, so it's +9. When you have, okay, when you don't have the parentheses, you need to pandas, you need to do the power first. So this one first. 3 square is 9, okay, and then you have this negative sign outside. So that's number 2. That's very different. Okay, so if you put into the calculator, if you say, oh, -3 square, if you just put that to the calculator, it will be -9. Some students, if I ask them to do -3 square, when they put into the calculator, they will just put -3 square, and then they get a wrong answer. So make sure without parentheses and with parentheses is very different. Okay, very good. Okay, now I want you to do now 3 and 4, okay? 3 and 4. Good job, Simon. Good job, Yo-Yo. Good job. Lynn, Arinka, very good. So let me go over that. Okay, -2 cubed is -2, -2, -2. So odd number of the negative, okay, negative, that's a negative number, 8. Okay, when you have this, remember pandas, you would do 2 cubed first, that's 8, okay, and then negative. So 3 and 4 actually the same. Okay, when you have an odd exponent and negative inside or outside, okay, it's actually the same. But if you have an even exponent, the negative, if it's inside the parenthesis or outside, will be different. Okay, very good. So I don't, okay, let's look at just a couple, okay, I don't need, let's look at 10 and 11, okay, 10 and 11. We do that very quick. Good job. Good job, Skyman. Good job, TX, Texas. Okay, good job, Arrington. Okay, so pandas, you would do this first, -3 cubed, -3 times -3 times -3, that's -27. Okay, and then you have a negative sign outside. Okay, that's +27. Okay, 11, do the same thing. You do the power first, so it's negative. Okay, and then -6, the square is +36. Oh, you finish all those. Okay, yeah, 19 and 20. Okay, 19 and a 20. 20 is easy. Okay, 19 and a 20, 21. How about that? 19 and a 21. Any number raised to the power 0 is 1. And when you have negative exponent, okay, negative exponent, change that to positive exponent. So 3 squared. but then do the reciprocal. Okay, so this one would be 1/9. Good job. Okay, I think you guys all ready for now the real SAT problems. Okay, let's look at example 1 here. So this is x plus, okay? If 3 to the power x plus 2 equals the y, then what is the value of 3x in terms of a y? Okay, so I will go over this. Okay, how do we start? Equals the y. Okay, and we want the value of the 3x. So you actually want to separate that. Remember the formula we did earlier? Okay, when I have this addition together, you can split that. Base, same base, you multiply, so you will add those exponents. So when I split those, you want to compare what's the difference between here. So you want to split the 3x, 3 to the power x by itself, okay, and then 3 squared. So 3 squared is 9 times the 9 equals y. So I need the value of 3 to the power x, so I need to divide by 9 on both sides. Okay, so final answer is y/9. Okay, good job. Any question on this, on the example 1? Okay, let's move on to example 2. Okay, example 2, if a plus 1 equals the 3 negative a plus 7. Okay, what is the value of a? What is the value of a? I will first give you 2 minutes-ish, okay, 2 minutes-ish, and then I will go over the strategy for this. Yeah, if you already find what is the a value, type that in the chat, but I will go over that definitely. Okay, you guys all good. I type in the chat for private chat. If you have, if your answer is wrong, I will just say check. But right now I have a lot of correct. I don't have enough time to do the thumb up. Okay, let me go over this. Okay, so when I have this equation, the left side and right side, I notice I have same base. When I have same base, I know this must be equal, okay? I will put those equal to each other. So it will be a plus 1 equals the negative a plus 7. The exponent need to be the same because the base is the same. Okay, and then this is the easy equation to solve. Put a on both sides, okay, and then 6 and then a equals the 3. So value is 3, okay? The a is 3. Very good. Okay, let's look at example 3. If I tell you 2a minus b equals the 4, what is the value of 4a divided by 2b? Okay. Once again, I will give you 2 minutes, then I will go over the strategy, okay? How do we find the value for this because it doesn't look like I have 2a minus b somewhere here. Those are all real problems from previous ACT. Okay, this one seems a little bit harder. Okay. So far, I received 3 answers are correct. Okay, now let me explain that. So what I need this value, so 4a over the 2b. So first I noticed I don't have the same base. So example 2 earlier, we have the same base, 3, 3. Right now I have 4 and a 2. They are different base, so I cannot just directly do the subtraction, right? It has to be the same base. Remember, it has to be the same base, and then I'll do the subtraction of the exponent. Now, can I make it to the same base? Yes. And okay, the easiest way to make 4 to base 2. So 4 itself is 2 squared. 4 itself is 2 squared. Okay, and then this is 4 raised to the power a, and then divide by 2 to the power b. Okay, remember, if you see those exponents, okay, very likely the first step, okay, you want to check, you want to convert that to everywhere same base. Okay, same base. Okay, now the top, remember when you have inside exponent and outside exponent, you multiply those. Okay, you multiply those. Okay, and as I mentioned in the beginning of the class, if you forget, okay, should I add or should I multiply? You can do a quick like expansion, find it out. Okay, so on the top is 2 to the power 2a, and then bottom 2 to the power b. Okay, now I have same base. Okay, now I have same base. So when I do the division, I know I need to subtract the exponent 2a minus b. Okay, very good. Now I know from the condition, I know 2a minus b is actually 4. This is actually 4. So this one equals 2 to the power 4, and then equals to 16. I'm not asking just the 2a, what is 2a minus b? So you need to plug in is 2 to the power 4. See, right? Just convert everything to the same base, okay, same base, and then use the formula to work on this. Question so far? Okay, let's look at next example, example 4. Okay, which of the following is equal to this? Okay, this is actually a formula that we haven't did in the beginning. So have AM. This is in algebra 2. I think algebra 1, we didn't go over this formula. Okay, so this is just down, it will be AM. So still have the M, but then this one will go inside. Okay, we'll go inside M here. And you can do a quick deduction. Okay, if you say, I don't know which one is M on the top or is M on the bottom, you can do a very quick one. So I know, okay, for example, square root A4. Okay, when you have nothing here, that means that's the square. Okay, we do not write here. So this one, I know square root of A4 is actually A square. Okay, so I know this one will be the 4 on the top and then the 2. So this is the 2. Okay, this is just to determine, okay, which one is on the top, which one is the bottom, if you forget about the formula. Okay, now we can directly just write this for, okay, x5. You will do what? Just x5, and then whatever the one in the root here, okay, that will be in the denominator. So it's x to the power 5 over 4. Okay, this is just nothing to play around. This is just the formula itself. Okay, let's look at example 5. If 4 root 3 equals root 3x, what is the value for x? Okay, what is the value for x? I have a couple of you really get quick. So I will give 1 more minute, one more minute. Okay, and then I will ask one of you, okay, what's your strategy? Oh, very good. Yeah, you let's wait just maybe 30 seconds for other students to think how to maybe just how to start. Okay, and then we'll get people to explain. Nice. Okay, I actually saw in the chat. Okay, quite different methods. Okay, now let's start. Yu, what is your method?
So I moved the 4 inside the square root sign. 4 squared is 16, and 16 times 3 is 48. And then since we already have a 3 inside, we just have to do 48 divided 3, which is 16. So it's C.
Excellent. Okay, let me repeat. Did you move 4 inside the square root, right?
Yeah.
Yeah. Okay, so Yu's method is, so for example, if I have 2, I can change that to root 4, right? Root 4. So now I have a 4 outside. Okay. Okay, I know 4 itself is root 16. So I'm going to do 4 root 3 itself. Move the 4 inside will become 4 square times the 3. Okay, everybody follow this? I moved the 4 inside the square root. Now it becomes 16, 3, because the vice versa, you can take that out is the 4 root 3, right? So I can do this, put in. Okay, now this whole thing, okay, will be equals the root 3x. Okay, root 3 and root 3 can cancel. Okay, root 3, or I can keep going. So root 16 times root 3 equals the root 3 times the root x. Sorry, I think maybe it made too complicated. So I know this is 6. Both are square roots, so 16 times 3 equals the 3x. Okay, and then x equals the 16. Okay, that's one of the method. You just move the 4 inside the square root and it becomes 16. Okay, and then you compare, because both are under the square root, both are under the square root. So this has to be equals this. 48 has to be equal 3x, and then you can solve for x. Andrew, I saw you typed up quite some. Oh, it isn't working. That's fine. Okay. Any other method? Anybody want to present a different method? This is Yu's method, but for inside. Do I have anybody have a different method? Okay, now Andrew typed his method in the chat window. So here is his method. Okay, let me use the green. And he said, okay, let's square both sides. Okay, square, I'm just put it right here. 4√3 equals the square root 3x. Okay, let me square the whole equation. Okay, square. Okay, so I have 4 square times the 3, right? √3, if you square, that's just the 3. And then when you have the √3x squared, it's just the 3x. Okay, and then it's easier to solve. 3 and 3 cancel, x equals the 4 squared, which is 16. So if you square both sides, okay, you will have this answer. So this is method 2. Okay, and then of course, method 1. Either way, okay, method. Okay, and Andrew also said, okay, similar method. So he moved the method 3, 4√3 equals the √3x. You can split that, okay? Root a times b is actually root a times root b. Okay, and reverse, it can be the same thing from right side to the left side, okay, from left to the right, okay? So you can split the a and the b, or you can combine them. So this one is basically √3 times the root x. Okay, and then the left one is 4 times the √3. Okay, so √3 and the √3 can cancel. Okay, and then you can solve this very quickly. Square root x equals 4, then of course x equals 16. So all different methods, okay, all different methods. You have reached the same answer. Okay, great. Yeah, when you also square both sides. Okay, so this is very good method. Okay, square both sides will probably my preferred way. It's just faster, but they all have no difference. Okay. Now let's practice. Okay, couple of them. If a to the power of negative half equals to 3, what is the value of a? Okay, if you type check, that means you need to check your answer. Double check. Good job, guys. Okay, so let me quickly go over this. Now we need to find the value of a, which means, okay, this one, I only need an a, okay? I only need an a. So there are probably multiple ways to do that, but one easy method. I want this exponent to become 1. Okay, I want this exponent to become 1. So what I should put here, okay, then it will be just a to the power 1. I have an inside exponent and I have an outside exponent. They need to multiply together to get 1. So I will put, let me use the book one. Okay, I actually want to not say multiply, raise to the power of -2. This way, negative, okay, this one will become 1. Okay, so very good. If I have, okay, I know this one equals to 3, right? Now, if I raise the both to the -2 and -2, so I know the left side will be just the a by itself. Okay, and then 3 to the power of -2, that's something you're very comfortable. It's 1/9. you switch, you change that to positive exponent, but do the reciprocal, And for this, you can also have one general method, plug in. Okay, if you have no idea how do I find a, right? This is worst case, you can plug in a. Okay, what is -9, -½ what is 1/9, -½ You can do that and then find the correct answer, which is B. Okay, this is just, overall, you have multiple choice. So this is, you can always, not say you can always try just plugging A, B, C, D to see which one is correct. Okay, let's move on to the next one. Those also appeared past SAT test as well. Okay, yeah, you guys so fast. I'm so slow to type the thumb up. Okay, probably some of I missed. Okay, so let's do that. Now remember, I said when you have the exponent, okay, and you notice, okay, I don't have the same base. Okay, let's change that to the same base. Can I change 8 to base 4? Can I change that to base 4? I cannot, right? Because 4 to the power 1 is 4. 4 squared is actually 16. So I cannot put 8 to base 4, but I know they can both have base 2. Okay, so 4 itself is 2 squared. Okay, and then you have this 2n plus the 3. The one on the right, 8 is 2 squared. Okay, and then raised to the power n plus 5. So I'm just replacing the 4 with the 2 squared, and 8 is 2 cubed. Okay, now remember you have inside exponent, outside exponent. You will multiply, okay, you will multiply those. So it will be 2 times the 2n plus 3 equals 2, the 3n plus 5. Now I have same base. So you are going to set those to get this. Those should be equal because I have same base. So when you set those equal to each other, okay, then you can solve for n. Okay, I will just not going over this details because that's just a quick linear equation. So n equals 9. So for this one, if you plug in A, B, C, D, you have big numbers. Okay, you will have big numbers. So it's you will still get the correct answer. It just probably take too long, wasted too much time. So if you can just look at base, let's try to make the same base on both sides. Questions so far? Okay. This should be a straightforward one. Everywhere I have the same base. Okay, everywhere I have the same base. A or B or C or D. Okay, so same base when I have the division. Okay, when I have the division, Okay, then I have to do the subtraction x minus y equals the 2 cubed. Same base, then the exponent need to be equal to each other, equals the 3. Okay, then x, of course, equal just y plus the 3. Okay, that's a straightforward one. A. Answer is A. Okay, if you choose the C, double check. Maybe you think x is more than a 3 more than, so. Okay, so this, let's do one more. If 3 to the power x equals 10, okay, what is the value of 3x minus 3? Okay. So already know 3 to the power x, 3x minus 3. Okay, that's the formula the other way. So I know I'm going to separate that to 3 to the power x, divide by 3 cubed. Remember, subtraction of the exponent is a division. I already know 3 to the power x is 10. Okay, and then 3 cubed itself is 27. So this is the answer, 10 over 27. You just, the formula, okay, you need to just freely manipulate. Okay, maybe control from left to right or from right to left. Okay, next one. Okay, Andrew, you're so fast. Oh, many of you. Oh, okay. So fast. Okay, let me wait 30 more seconds and then I will go over how do we do that. Okay, we have now two variables. Okay, we have two variables. The base is x and y here. Okay, the ask the value of x5, y5, x5. I only know the 2, 3, and 3, 2 here, but you notice if I add those together, 2 and a 3, 3 and a 2, that's 5. Now, if you add exponent means what? You are multiplying them. Okay, x2 times x cubed, that will be x5, right? So if I multiply those two together, so x squared y cubed, multiply this x cubed y squared. Okay, it's 10 times the 8, 80, but I know those exponents need to add it together. 2 plus 3, that's 5. 3 plus 2, that's 5. So that will be 80. So you would just look at, okay, the pattern, okay, how should I get 5? How should I get 5? 2 plus 3, that's 5. When you have the exponent, you add it together, then you need to do the multiplication here. So final answer, 80. Very good. To the next one. Okay. Yeah, this is to check if you remember the formula. When you have a fraction, okay, when you have a fraction in the exponent, you have the radical, okay, you have the root. Good job. So 2a need to be inside, okay, and then b will be outside. So answer. So I saw quite a few of the problems. If you have fraction in the exponent, it's basically just to checking if you remember the formula. Where is what is this number outside? Okay, what is the one inside? Okay, I will give you a little bit more time on this. Okay. Okay, you have x, you have y, and you have z. And if you already answered, can you also type, okay, what's your strategy? I just want to see how you did that. Okay, very good justification here. Okay, so let me go over the strategy. Okay, this look like to some students probably just all over the place. I have a square, I have a 3z. Okay, what happened? Okay, that doesn't seem you can actually quickly. But if I look at y cubed and y9, okay, I actually know I can do something that. So if I cube, okay, if I cube both sides, giving you the x squared here. So if I have x6 equals the y9, right? If I cube this both sides, I have x to the 6 equals the y to the 9. External exponent, you need to multiply that. Okay. Now I also know this one equals the y9. So this is also equal to y9. So I know x to the power 6 equals x to the power 3z. Same base, set this equal, exponent equal, and then c just equals the 2. Okay, very good. I saw different methods, right? You can just do the, you can put the x, isolate x, and then do the 3z, yeah? Okay, yeah, okay, here, let me just introduce, because I saw 3 students did it this way. So from here, x squared equals the y cube. You can just say x itself is actually y, the 3/2. Okay. And then you can work out this. So it will be x3z will be x. The 3z will be the y 3/2 times the 3z, and then equals the y9, and then you can solve for the z as well. Good job. This is a good one. Okay, multiple times we saw this type questions on the ACT. Excellent. So when our class starts next week, okay, I will just like this each unit, I will start to have some example, and then we will practice example. I show you how to do the strategy for some general type of the problems related on this related topic. Okay, and then we will do practice. But after week 1, you will have homework from the College Board practice test. Okay, and then every time when we start new class, the first 20 minutes or 30 minutes, I want to go over some problems that you have on the homework, okay, on the homework, and then we will continue on the new topic, some examples, strategy, and some practice. Okay, let's look at this one. So when I have, looks like I have 2 everywhere. How do I find a k? When I saw this x plus 3, I want to just expand it out. So it will be 2 power x and then times 2 to the 3. Okay, when you add the exponent, you multiply that. And then minus 2x equals k times the 2x. Now 2 cubed is what? 8. So 8 times that 2x minus the 2x equals the k 2x. I can factor that out. So 8 times of the 2x minus 1 of the 2x, that total is 7. Okay. 2x equals the k times the 2x. Okay, and then k equals 7. So k equals 7. So you will just expand it out. Okay, expand it out. Okay, and then figure out what should be the k. This actually I saw multiple times on the SAT problems. So we only have 4 minutes left. I do have some questions, but yeah, let's just finish one more. Okay, finish one more. Let me do something. Oh, how about this? So we had earlier, we had 5 examples earlier, and then we practiced. This is one example. I actually mentioned the three different methods. Okay, actually, students actually showed me all the different methods you did. So this is the one with those different methods. Good job, Wendy. So fast. Arinka, very good. Good job, Skyman. What method did you use so far? The 3 student. Yo-yo, very good. Yeah, square, right? Square both sides. Remember, we had 3 methods. Either you can you can take the 2 inside, 3 inside, or just the square both sides. Okay, square both sides. When you square both sides, I have 4 times the x plus 2. Okay, and I have the 9 times the 2. Okay, and then it's easy. 4x plus 8 equals the 18. Okay, and then x just equals 2 half, 2.5. Okay, you square both sides, solve for x, yes. And I put the right as 18 and then solve with the left. Okay, so you can either, this is the square both sides method. Okay, and then of course you can put the 2 inside, right? If you put the 2 inside, it's basically the same. Put the 3 inside, 3 square, 9 times 2. Okay, and then solve it. Okay, very good, very good. Okay, this is just one of the topic. I spent some time on this. So in the class, okay, one topic probably will not have this much time, but we definitely will go over all the examples and then practice a few, and then second topic. So each week we will do all three topics, okay, 3 topics together. And hopefully after 24 hours, the 12 weeks, we'll cover all the topics. How much homework will be given? The homework you expect every week may do about 90 minutes to 2 hours. I will give you the College Board, some section, and then some homework from the textbook page that I will give that to you. Now, many of you, I think, probably will work, what the hours probably don't need that 90 minutes, because based on today's reaction, okay, a lot of you actually did the question very fast. So, but roughly definitely have at least 1 hour, because the College Board practice test will give you some of the non-calculated part and the calculated part. So after all 12 weeks, hopefully we will finish majority of the College Board. Currently, they published 8 practice tests. Hopefully we can finish majority of that. This is just one semester class. This one semester class. So we'll finish all the topics in 12 classes, 24 hours. Any other questions? If not, okay, if you are interested, go ahead, register the class. Okay, and hopefully I will see you next week. Bye.